Hi everyone, this is lesson electric force in which we are going to solve one question based on Coulomb's law. Before we start solving the question, let's review the main physics ideas we need. First, we will use Coulomb's law. Coulomb's law tells us that electric force between two charges depends on the size of the charges and the distance between them. So the electric force is given by Fe equals K times Q1 Q2 by R square, and we have to mention the direction. Now, Fe is the electrical force between these two charges, K is the Coulomb's constant, Q1 and Q2 are the magnitude of the charges respectively, R is the distance between those two charges. So, this will give us the magnitude of electric force, and since force is a vector quantity, we need the direction. Now, the direction of the force depends on the signs of the charges. If we have like charges, so two positive charges push away from each other and two negative charges also push away from each other. So like charges repel, and since these like charges will push each other, we will get the direction of the force. So if we have positive charge and positive charge, let's say we have these two charges plus Q1 and plus Q2. So the force that Q2 is experienced from Q1 would be repulsive force. So this plus charge is going to repel this charge Q2. So in which direction this charge Q2 will go? Towards the right side force. And again, Q1 will also get repelled from Q2. So we will draw the direction like this. And again, opposite charges attract, so a positive charge and a negative charge pull towards each other, and hence we will get the direction. So opposite charge attracts. So if we have positive charge and we have negative charge, so this positive charge will be attracted toward this negative charge, and this negative charge will be attracted towards this positive charge. So the force experienced by the positive charge due to negative charge would be attractive, and this positive charge will tend to go towards the negative charge. So this we can say, if this is charge 1, this is charge 2, we can say this is the direction of the force vector, force on 1 due to 2. So you can see how this is an attractive force. Similarly, charge 2 will have the tendency to get attract towards charge 1. So the force vector would be towards charge 1. So we can say force on charge 2 due to 1 is towards the west direction or towards the left side. So this is how we have to draw the force vectors. Another concept is angled force. So whenever we get the angled force, it's very important for us to resolve those forces into its horizontal and vertical components. So whenever a force is angled, we cannot simply add it directly to horizontal or vertical forces. We must first resolve the angled force into its component. This means that we split the force into Fx, that is the horizontal component, and Fy, that is the vertical component. So let's say we have an angled force like this. So we have to, and this is making an angle theta. So we are required to determine the horizontal component, which would be this, and the vertical component, which would be this. And using the trigonometry, we have to find what is the horizontal component. So let's say we have force F. So this becomes the Fx, which is the horizontal component, and this becomes Fy, which is the vertical component. Now we can use trigonometry to determine Fx and Fy. So for this, you can see this is a right angle triangle, and we are going to use SOHCAHTOA in order to determine the horizontal component and the vertical component. So Fx would be the adjacent of this right angle triangle, right? So adjacent of this triangle is Fx, and F is the hypotenuse of this triangle. So we can easily calculate Fx as F cosine theta. And as you can see, Fy is the vertical component, and Fy is also the opposite of this right angle triangle. So since this is the opposite of the right angle triangle, so we will get Fy as F times sine theta. So first you have to identify if you have the adjacent. So adjacent would always be F cosine theta, and the opposite of the triangle would always be F sine theta, because this is how the trigonometric ratios are related to each other. We also have to take care of symmetry. Whenever we have the equal and opposite forces, they always cancel each other. In final answer, we have to always include magnitude and direction. So now let's solve the question. So I'm moving on to the question. So three identical positive point charges are placed on a coordinate system. The left charge is at x equals negative L, the right charge is at x equals positive L, and the bottom charge is at y equals negative L. Each charge has Q equals 7.5 times 10 raised to the power negative 6 coulomb and L is 0.25 meter. Determine the electric force on the bottom charge, the charge on the right, and the electron placed at the origin. So as you can see, the magnitude of all the charges of all the three charges in this setup is same, which is 7.5 times 10 raised to the power negative 6 coulomb. You can see L is also given to us, which is 0.25 meter. K is the known value. So K is the Coulomb's constant. The value is 8.99 times 10 raised to the power 9 Newton meter square per coulomb. And QE value is also given to us, which is the charge on the elementary particle, and its value is 1.6 times 10 raised to the power negative 19 coulomb. So now we can see we have the setup of three charges here, and in different parts we are going to find the force on the different charges. Now let's determine the net force on the bottom charge in part A. So we are going to mark these charges as charge 1, charge 2 and charge 3. Now charge 3 is going to experience an electric force from charge 1 as well as from charge 2. So first we will consider the force between charge 1 and charge 3. So for that, first we are going to join the distance between charge 1 and charge 3. So this is the distance between these two charges. So I will mark the centers of these four charges and will join them using a straight line. So this is R1, 3. That means the distance between charge 1 and charge 3. Now, charge 3 is going to experience a repulsive force from charge 1 because both of these charges are of positive nature. So charge 1 is going to push charge 3 away. So because of this, charge 3 will experience a repulsive force towards the right side and along the diagonal. So this will be force on charge 3 due to 1. This is the repulsive force that charge 3 is experiencing. And force always acts along the line joining the two charges. Distance. Now we do not know the distance between charge 1 and charge 3. That means R13. So we need to calculate this distance as well. Now, in order to calculate this distance, we can use basic trigonometry. So you can see, I can highlight this triangle here. So you see this triangle. Triangle formed is a right angle triangle. I will draw this triangle here. Here the charge 1 was present. Here the charge 3. Here is the origin. And this length is L. This perpendicular length is also L. And this is R13. Now using this right angle triangle, we can determine R13 using Pythagoras theorem. So Pythagoras theorem states that R13 is square root of sum of the squares of these two perpendicular lengths, which is L square plus L square. And as we know, L square plus L square is 2L square. So this will become square root of 2 times L. Now on substituting L with the numerical value given in the question, we can easily determine what R13 is going to be. So this is going to be square root of 2 times 0.25, and if you will solve using the calculator, we will get the value, and the value is 354 meter. So this is 0.354 meters. So we got the value of R13 using the Pythagoras theorem. Now, this was the force and the distance between charge 1 and charge 3. Now, if you will consider here, the distance between charge 3 and charge 2 will again be the same. Why? Let's join these two charges now. So I will join these two charges, charge 3 and charge 2. Now again, you can see if I will consider this right angle triangle, I have the same values. So this is charge 2, this is origin, and this is charge 3. This length is also L, this perpendicular length is also L, and this is the hypotenuse, which we can mark as R23, which is the distance between charge 2 and 3. So now again, this R23 is the hypotenuse of this right angle triangle, and R23 will also be given by the square root of the sum of the squares of the other two perpendicular lengths, which is L square plus L square. So again, we will get the same thing here as R13. So we can write R13 equals R23. So both the distances are same. Now let's draw the force vector that charge 3 is going to experience due to charge 2. So charge 3 and charge 2 again are of same nature. Charge 3 is going to experience a repulsive force because of charge 2. So charge 2 is going to push charge 3 away along this diagonal and towards the left. So this will be F32 force vector. Now here we have to notice one thing, that force 3, 1 and force 3, 2, both the force vectors are angled forces. They are making some angle with the respective vertical line or the horizontal line. So let's quickly determine the angle and then we can resolve these two forces into its respective components. So first I will draw a reference vertical line and then reference horizontal line. So here you can see this angle is 90 degree. In this right angle triangle, this length is L, this length is L. So we can say opposite angles are going to be equal and they would be of 45 degree. So let's understand this math. If this is 90 degree, this length is L, this length is L, opposite sides are equal, so opposite angles will be equal. So if this angle is X, this angle will also be X, and this is 90 degree. So can we write X plus 90 degree would give us 180 degree, because all the three angles of a triangle sums to 180 degree. So X plus X would be 2X plus 90 degree equals 180 degree. So now I can solve this equation. 2X equals 180 degree minus 90 degree. So 2X equals 90 degree. So X equals 45 degree. Otherwise also it's the simple understanding. If we have opposite sides are equal, one of the angle is 90 degree. So the other two angles have to be 45 degree each. So this is 45 degree and this is also 45 degree. Now, if this angle is 45 degree, this angle will also be 45 degree using vertical opposite angle. So F31 is making 45 degree with reference vertical line, and F32 will also by same logic will make 45 degree with the respective vertical line. So now we can resolve these two forces into its respective components. So this is F31 and I will make a reference vertical line here, and with this vertical it is making 45 degree. Right. Now we can resolve this force into its horizontal component and the vertical component. So this is the horizontal component F31 as you can see, and this is the vertical component of F31. So now this is 45 degree. This is going to be the opposite. So opposite component is always sine component. So this is F31 sine 45 degree. And this is F31 cosine 45 degree. Now I will resolve the other force, which is F32. Now this is F32. Now this F32 is making 45 degree with the vertical. Now let's see the horizontal component would be towards the west side, and this is going to be the respective vertical component. Again, this is the angle. Opposite to the angle would be horizontal. Opposite to the angle would be sine component. So I can write this is the horizontal component, which is F32 sine 45 degree. And this is the vertical component. Since it is the adjacent, so it would be F32 times cosine 45 degree. So now we got the vertical component of both the forces and horizontal component of both the forces, right? Now the important point to consider here is both the forces F31 and F32, they are going to be same. The magnitude of these two forces are going to be same. Let's see why they are same. F31 and F32 depends on K times Q1 Q2 by R square. K for both the forces is going to be same because K is constant. Q1 Q2. So for F31, Q1 Q2 is charge 1 and charge 3, which is same plus Q plus Q. And for F32 also we have Q value and Q value. So both the magnitude of the charges are same and the distance between the charges which we have calculated, R13 and R23 are same. So these two forces are going to be same, and the magnitude we can calculate using the Coulomb's law. So let's determine the magnitude of either force. So we can write F32 is same as F31, which is K times Q1 Q2 by R square. On substituting the value, we will get 8.99 times 10 raised to the power 9 times 7.5 times 10 raised to the power negative 6 times 7.5 times 10 raised to the power negative 6, because this is a 2 over R square. R square is, we have calculated R13 and R23, which was 0.354 square. Now we can solve this using the calculator, and we will get 4.05 Newton. Now, as you can see, now we have also resolved the diagonal forces. Let's complete the component or the force summary for these forces. So the x component of F31 will be F31 sine 45 degree, and for F32 is F32 sine 45 degree. This would be facing towards east, and the direction of this is west. Now we have already seen that F31 and F32 are same, which is equals to F. So we can just substitute this with F and F, which we have calculated 4.05 Newton. Now the important thing to consider here is F sine 45 degree is towards east, F sine 45 degrees towards west. So both of these x components, the magnitude are going to be, but the directions are opposite. So you can see one force is here in the east and the other component is towards the west with same magnitude. So the net x component, F net x, will be 0 because it will cancel. And similarly, if I'll write the y component, it would be 1 cosine 45 degree, and the y component of F32 would be F32 cosine 45 degree. And as we have again seen that F31 and F32 equals F, so I will just write F here. So F cosine 45 degree from F31 is facing in the south direction, and this is also in the south direction. Now, since both of the vertical components are pointing in the south direction, the resultant will also be in the south direction, and we can add these two forces because they are in the same direction. So we will get the net F force in the y-axis, or we will get the net force which is facing towards the y-axis. It would be 2 times F cosine 45 degree, and what would be the direction? South. Now we can solve this. We have already determined F, which is 4.05. So it would be 2 times 4.05 cosine 45 degree, and the direction will be south. On solving this, we will get 5.72 Newton. So this will give us 5.72 Newton force towards the south. So there's only net force that is acting downward, F net, and what is the direction? South. So net force is 5.72 Newton south, because the horizontal components cancel each other. So the net force is on the bottom charge is 5.72 Newton downwards or south, or in the negative direction. Either way we can. So this is how we have to solve when the components are given to us. So this is the total net force that we will get on the bottom charge. So this was the part A. Now let's do part B, in which we are required to determine the net force on charge on the right. So this is charge 1, this is charge 2, this is charge 3. In this case, we are required to determine the net force on charge 2 due to charge 1 and charge 3. So let's begin with drawing the force vector that charge 2 is going to experience from charge 1. So before that, I will join these two charges to know the distance between these two charges. So as you can see, the distance would be twice L. So 2L is the distance between these two charges. Now, charge 2 and charge 1, both of them are positive nature. So charge 1 is going to push the charge 2 away towards the side east. So this is how we will get the electric force vector on charge 2 due to 1. Now, the other charge that is going to exert force on charge 2 would be charge 3, which is the bottom charge. Now, in order to determine the force vector, I will join these two charges first. So charge 3 and charge 2 are again separated with the distance r23. This distance we have already calculated in the previous part. Now the force is going to be repulsive because charge 2 and charge 3, they have the same nature. Charge 3 is going to push charge 2 away like this along the diagonal that we have joined and in the upward direction. So this is force on charge 2 due to 3. So we have drawn both the force vectors. So now let's start doing the calculation work. So first we have to determine the distance from the left charge to the right charge, which is 2 times L. I can substitute the value of L, which is given to us in the question, which is 0.25. So on solving this, we will get 0.50 meter. Now in step 2, we will calculate the force from the left charge. We are going to use the Coulomb's law, which is K times. So F21, which is K times Q1, Q2, both the charges are of same nature. So I can just write Q1, Q2 over R square. On substituting the value, 8.99 times 10 raised to the power 9 times Q1, Q2 is going to be 7.5 times 10 raised to the power negative 6. I can do the square because both the values are of same magnitude, and R is already calculated here, 0.50 square. We will get 2.02 Newton east. Now step 3 is to determine the distance from the bottom charge to the right, which we have already calculated in the previous part, which is 0.354 meter. Now we can use the Coulomb's law to determine force on charge 2 due to 3. Again, we are going to use Coulomb's formula or Coulomb's law. K times Q1 Q2 by R square. I can plug in the values. I will get 8.99 times 10 raised to the power 9 times, since both the magnitude of the charges are same, I can just do 7.5 times 10 raised to the power negative 6 square. R is 0.354 meter. Square of this, we will get on solving 4.05 Newton force as we got in the previous part. See the force vectors. F21 is along the positive x-axis. We do not need to resolve it, but F23 is an angled force. So we need to resolve it into its respective x and y components. So let's draw F23 here. Now this, before resolving, we should know the angle that it is making. As we have previously seen that this angle is 45 degree. So this will also be 45 degree. So it is making a 45 degree with the horizontal. So now I can complete the horizontal component and vertical component. So this is horizontal component F23x, and this is the vertical component F23y. Now since you can see this is 45 degrees, so opposite to this would be the sine component. So we would write this as F23 sine 45 degree, and the horizontal component would be F23 cosine 45 degree. Now let's determine the values of the y component and the x component. So F23 we have already calculated. It came out to be 4.05. So it would be 4.05 sine 45 degree. So if you will calculate this using the calculator, we will get 2.86. So the y component is 2.86 Newton. And as you can see, it is acting towards north direction. And F23 cosine 45 degree, again I will write F23 as 4.05 cosine 45 degree, and if you will use this using the calculator, you will get 2.86 Newton. So it is say 2.86 Newton, and this was in the east direction. So if we, let's complete the summary. So F23 we got x component as 2.86 Newton in east direction. For F21, we have the force along the x-axis. So we will just write this under the x component, which we have calculated here, which is 2.02 Newton. and it is also pointing towards east. The y component of F23 came out to be 2.86 Newton, and the direction is north. There's no y component for this. So we can write the F net x that we will get. Both of them are pointing towards east, so we can just add these two forces. On adding these two forces, we will get 4.88 Newton, and the net force is again pointing towards east. Now the y forces, F net y is just the same, 2.86 newtons north. So we got one x force. So one force along the x-axis, F net x, and one force along the y-axis. So this is F net x, this is F net y. And again, using the Pythagorean theorem, we can get the resultant, which is the hypotenuse of this right angle triangle mid. So F net can be calculated as square root of F net x square plus F net y square. So we can write this as 4.88 square plus 2.86 square. Again, if you will solve this using the calculator, we will get 5.66 Newton. So on solving, we will get 5.66 Newton as a whole F net. So for the direction, we can use tan theta. So theta equals tan inverse of F net y over F net x. F net y is 2.86 over 4.88 Newton, and theta will comes out to be 30.04 degree. So we can write F net is 5.66 Newton, 5.66 Newton, and what is the angle that is being made? 30.4 degree with positive x-axis. So the resultant is 30.4 degree with positive x-axis. Or you can also see it was initially at east and then moved towards the north. So we can write east 30.4 north. Let's solve part C, in which we are required to determine the net force on an electron at the origin. So electron is negative and each surrounding charge is positive. So the force between electron and a positive charge would be attractive. So we have to keep this thing in mind while we are determining the force vector. Secondly, this electron is going to experience force from all the three charges: charge 1, charge 2, charge 3. So we will begin by drawing the force vector between all these three charges, and then we will solve the net force. So let's draw the force vector between charge 1 and the electron. So first I'm going to join these two charges, charge 1 and the electron. So the distance between charge 1 and electron is L, and electron will have the tendency to attract towards positive. So the force vector or the force on electron due to the charge 1 would be towards this charge. So this is the force vector on electron due to charge 1. As you can see, it is pointing towards west. Similarly, the force vector between electron and charge 2, first I'm going to join these two charges. So as you can see, again, this is going to be the attractive force on the electron. So electron will have tendency to get attract towards charge 2. So this is how we are going to make force on electron due to charge 2. Again, you can see force on electron due to charge 1 and force on electron due to charge 2. They are going to have the same magnitude because the charges under consideration, charge Q and the electron, is same for both the forces, and the distance for both the forces is again same, which is L in each case. Now we are going to draw the third force due to the bottom charge, and again first I'm going to join these two charges, and the force would be attractive and would be along this line, which is FE3, and which is in the downward direction. So these are the three forces that we have drawn that electron is going to experience because of the respective charges around it. Now we got these three vectors, FE1, Fe2 and Fe3 vectors that are acting on an electron due to the other charges present around it. As we can see here, Fe1 and Fe2 are going to be same in magnitude, but they are in the opposite direction. So we can say that these two forces will cancel each other. So the left force is going to be equal to the right force. So there would be no effect of these two forces as a whole. And then we are left with only with the bottom force, which is Fe3. So we have drawn all the forces. We know that Fe1 is going to be equal to Fe2. So they are going to cancel each other. The remaining force is just between the electron and the bottom charge. So we are going to calculate that force. So using the Coulomb's formula, we can determine this force, which is Fe3 equals K times Q1 Q2 by R square. I can substitute the values. K is 8.99 times 10 raised to the power 9. Q1 for the electron is 1.6 times 10 raised to the power negative 19 coulombs. And Q2, this charge is already given to us, which is 7.5 times 10 raised to the power negative 6 over R square. R is just the L in this case. And the distance L is 0.25 meter. And I will write the square of it. So on solving this, we will get 1.73 times 10 raised to the power negative 13 newtons. This is the force that we are going to get. So here we cannot write the force summary because there was no angled force. So this is not required here. So the net force is just 1.73 times 10 raised to the power negative 13 newton. And what is the direction? South. Now to summarize, in part A, we found the net force on the bottom charge. The two diagonal forces had horizontal components that cancelled. The vertical components both pointed downward, so they added. In part B, we found the net force on the right charge. One force was directly to the right and the other force was diagonal. We resolved the diagonal force, added the components, and then found the resultant. In part C, we placed an electron at the origin. Because the electron is negative, the positive charges attracted it. The left and the right forces cancelled, and the bottom charge pulled the electron downward. The biggest thing to remember from this question is that electric force is a vector. So we must always think about the direction. If the force is diagonal, resolve it into components. If equal forces act in opposite directions, they cancel. And always check whether the charges attract or repel, because this is going to give you the direction of the force.